All right. Hello, everyone. So today's lecture is going to be on acid and hydrate formula creation. Okay. Um, so, all right. Um, so this is doing basically the opposite of what we've been doing, which is, in this case, they're going to give us the names, and we're going to figure out the formulas from those names. Okay. So for the acids, okay, we've got an acid as a definition is any substance that gives off hydrogen ion when dissolved in water, okay, when dissociated. Acid formulas identify the substance as an acid, which should be very easy because the name will end in acid, okay. All acids have hydrogen as their cation, H plus 1. So that means if it's an acid, you are automatically going to start with a hydrogen as the positive ion, okay. You have to figure out what the anion is. You do these. We're going to do these like we do the ionic ones. We're going to get the charges and cross them. Okay. Um, if the name has the prefix hydro, then the anion is monatomic. Look up the anion on the periodic table to find the charge. If the name does not have the prefix hydro, then the anion is polyatomic. Find the polyatomic ion that ends in 8. This is important because there's more than one. Okay, find the polyatomic ion that ends in 8 with the same element name from the acid using your polyatomic anion sheet. Okay, and as I just said, create the formula the same way you create the ionic formulas. Use the charges and crisscross method to create them. So, example here, and we've got two examples. Okay, I used hydrosulfuric acid and sulfuric so you can kind of see the difference. Okay. So hydrosulfuric acid, we know it's an acid, so we start with H plus 1. Now, it has hydro at the beginning. That means our anion, the negative thing, is monatomic from the periodic table. So sulfuric comes from sulfur. So you look sulfur up on the periodic table, it's a -2. So you put S -2 or 2 negative. Then all you do, you cross down, and we end up with H2S. Okay? All right. Let's take a look at sulfuric acid. Again, acids, we start with H plus 1. There's no hydro at the beginning. So what this tells us we need to do is we need to use the polyatomic. Find the polyatomic ion that ends in 8 with the same element name as the acid. So we want sulfate. Okay, so we look on our polyatomic ion sheet, and we have here sulfate. Now here's why it's important that you pay attention to the 8, because see how there's sulfite? That's different. We don't want the sulfite, we want the sulfate. So for the acids, any polyatomic that you get off of this chart, you're going to want it to end in 8. So sulfate, SO4 -2. So SO4 to negative, we cross down, right? We get H2SO4. All right, I'm going to walk through these down here. Okay, so they're all acids. I'm going to start each one with H plus then, okay? So we've got hydro. That tells me I go to my periodic table. I want to find the one that would give me chloric, so that would be chlorine. Chlorine, -1. So I cross down, and I get HCl. Okay. Nitric acid, no hydro. So again, acids start with H plus. That means I go to my polyatomic ion sheet, and I want to find the thing that's got nitric, so it'd be nitrate. I find, let's see, where is it? Nitrate here, NO3 -1. So cross down, we get HNO3. Okay. Carbonic acid. No hydro. So we want carbonate, CO3 -2. Again, cross down. Okay. Hydronitric acid. So it's got the hydro, right? So that's anion monatomic. So nitric would be from nitrogen. I look on the periodic table, nitrogen is a -3. Okay. And the last one, acetic acid, again, no hydro. So it means off the polyatomic sheet. So it'd be acetic would be acetate. That's this one here. Okay. Now don't freak out because it's got 3 elements in it. It doesn't matter. We treat it all as one thing. So it's C2, H3, O2, -1, cross down, and we end up with H, C2, H3, O2, acetic acid. All right. So that's it for the acids. Okay. Now I'm going to go to the hydrate part of the notes, which is the back on yours. Okay. All right. A hydrate is any solid ionic substance that has water locked in its bonds. I think we talked about that before when we kind of went on, first started going over these. All right. Hydrate formulas. Identify the substance as a hydrate. So how do we know from the name if it's a hydrate? The name will end with one of the prefixes, like the monoditri things, and then hydrate. Okay, so like here in the example, calcium nitrite tetrahydrate. It'll end with that. Create the first part of the formula using your ionic formula creation method. Do the charges in the crisscross. Okay. Put a dot to separate the first part of the formula from the hydrate part. Identify the number that goes with the prefix beginning to the hydrate and put that as a coefficient. Then add H2O for the hydrate part after the coefficient. So let's walk through this. Calcium nitride tetrahydrate. Okay. Calcium off the periodic table, we look it up, it's a 2+, right? We're just looking here. Calcium +2. Nitride, IDE tells us it's a monatomic off the periodic table, so we look up nitrogen. Nitrogen is a -3, so we get this. Okay. And all we do is we cross those down. Okay. We get Ca3N2. Then we put a dot. Okay. Then tetra. The tetra part, tetra is 4. That's the monoditris. If you don't remember them, they're in the binary molecular, the covalent naming notes. Okay. And then, so we put 4 for tetra, and then we put H2O for the hydrate part. Okay. That's all there is to it. So, aluminum hydroxide, heptahydrate. Look on the periodic table. Aluminum is a 3+. Hydroxide is a polyatomic, right? So hydroxide, you find on here, OH -1. Okay, we cross down, keeping in mind that since hydroxide is a polyatomic, we want to say we have 3 of these whole things. So we need to put parentheses around the hydroxide. The 3 goes on the outside. So we get this. Hepta gives us 7. Hydrate gives us the H2O. So it's Al parenthesis OH parenthesis 3 dot 7 H2O. Okay. Let's try a few examples here. Okay. Potassium oxide trihydrate. So potassium is K plus 1. Again, getting that off the periodic table. Oxide means it's oxygen. O2 negative. Cross down. We get K2O. Then a dot. Tri is 3. Hydrate H2O. Iron 3 sulfate pentahydrate. Okay, iron is Fe. If we look on the periodic table, from what we have marked, we don't know the charge for iron. Right? That's what the Roman numeral is for. Remember, this is the cation charge. Okay, so Fe is a plus 3 sulfate. Sulfate is a polyatomic, ends in 8. So you go here, sulfate, over here, SO4, negative 2. Okay, we look for reduction, we can't, we cross down, and we get Fe2, parenthesis, SO4, parenthesis, 3. 3 goes on the outside. Pentahydrate, so dot, penta is 5, hydrate, H2O. All right, I'll go through the next two a little more quickly here. Just kind of the same thing again now for these. So beryllium, beryllium is a plus 2. Selenide is Se. Selenide is over here on the right, is a negative 2. So we can reduce these. So we reduce it to a plus 1 and a minus 1. And cross, we get BeSe. Octahydrate, so dot, octa is 8, H2O. Zinc carbonate hexahydrate. So zinc is Zn, Zn, plus 2. Carbonate is CO3 negative 2. These cancel or reduce. Cross down. We just get Zn CO3 dot hexa 6 hydrate H2O. There you go. So that's it for those. Okay, good luck. Let me know if you guys have any questions, and I'll see you later.